Hello, hello. I am going, hello from Liverpool. It is the middle of the night here in Liverpool, and you are seeing the eerie glow of 1 in the morning here on the west coast of England. I'm going to make sure that you all can see me and hear me. I'm going to ask my trusty assistant at headquarters back in Boston to confirm that I'm good. All right. Well, this is an adventure. I have never taught a course from 1 to 3 in the morning, but one thing I always say to my students is that the GMAT is going to throw things at you that you have never seen before, and it's going to sort of activate your amygdala at some point. It's going to test your anxiety. It's going to test your ability to cope with completely unexpected situations, and you're going to want to respond with fear and panic. And I want to tell you a quick story. I had a student who is a very good student. He is a 690 test taker, and he was trying to push himself over the top this past week, and he, by all accounts, by his own account, got on the test and, quote, forgot every system and strategy that he had practiced with and just started doing things as fast as he could. So this is the equivalent of going into battle and panicking and throwing up all of your weapons and just running and seeing what happens. You need to keep your wits about you. And one thing that I always pride myself on is the ability to do any of these questions at any time, day or night, no matter where I am and no matter what kind of question it is. So I will struggle, as you might see tonight, so fair warning, but I will do my best to stay with you and to be responsive and entertaining. I'm going to be a little more quiet than usual because there are a lot of people sleeping around here, but I am in my own room. I hope it is soundproof, and let's get going. So first of all, I want to thank everybody who sent me emails. Several of you sent me emails. Please continue to do that. I am always available by email, and I believe everyone who emailed me I got back to within a very short amount of time. So please continue to be in touch. All right, let's pick up where we left off in the third lesson, the quantitative lesson. Before I start, if you have any questions about the GMAT or your studying or the history of Liverpool or a Liverpool football club or anything, go ahead and put those in the chat box while I load up session 3 of math. Okay. All right, I don't see, oh, great. Oh, everyone wants to know why I'm here. So I would love to tell you that I'm doing business development here, and indeed I did meet some people who might become clients for my business, which is starting impact investing funds and doing venture capital in impact investing. But this is actually a family trip. My stepdad, who never graduated from college, decided to do an online MBA, and he has been toiling for the last 3.5 years online every night, pretty much every single night for 3.5 years to get his MBA. And today, at age 62, he did not graduate. He has never been to a graduation of his own, but he graduated from the University of Liverpool here with merit and got his master's in science with the focus in business. So not exactly an MBA, but the British equivalent. So really, really great 3-day trip to support him and the family. So that's why I'm here. Okay, never too late. All right, we are going to go from slide, here we are. So slide 20 of the algebra set. Okay, so just a little bit of review on inequalities. The main thing about inequalities is that they are testing to see if you know that when you multiply or divide by a negative number, the sign flips. That is the #1 thing to remember on inequalities. Okay, so when you solve inequalities, especially in problem solving, but also in data sufficiency, make sure you test both positive and negative numbers. And otherwise, you can treat an inequality sign greater than or equal sign, or greater than or less than sign, very, very similarly to an equal sign. All right, let's try and go. I know we did slide 19, example number 5 last time. So let's try and do example number 6 right now. I'll give you about a minute and 40 seconds. So go ahead, do the best you can with example number 6. Okay, I'll give you another 35 seconds or so. Okay, let's put up the poll and see how you did here. And begin. Very interesting. Okay, well, almost an even split. Check this out. Well, let's see. 57% of you, a bare majority, got the correct answer, and 43% guessed the second best but still wrong answer. Okay, so let's do this very quickly. Let's see if my pen works even in England. Yes, hello. Okay, so the answer is E. Why is it E? Well, is A over B less than X over Y? What's the answer? Who knows? Nobody knows. I don't know anything about A or B or X or Y. So now it says A is less than B. Great, but that doesn't tell me anything about X or Y, so that's clearly not enough. Same thing for statement 2. So already we can eliminate A is gone and D is gone, and then B is gone. So the only ones that are really useful are C and E. So if I know that A is less than B and X is greater than Y, is A over B less than X over Y? Well, the easiest thing to do here is to pick some numbers. So if I said A is 1, A and B is 2, then if A is 1 and B is 2, is that less than? And then X is greater than Y. So if X is greater than Y, why don't I just make X and y. I just make x2 and y1. So x is 2 and y is 1. So is 1/2 less than 2? Yes, it is. But now let's make a less than b, so -1 and 2. And here we have do the same thing, 2 and -1. So now we have -1/2, right, is less than, and then x is 2 and y is -1. Oops, -1. And so now we have, is 1/2 less than -2? No, it is not. It is not. So this is not true. This is fake news. That is fake math. So 1/2 is not less than -2. So you can basically satisfy both conditions. A is less than B and X is greater than Y, and then come out with something that is both true and not true. So if you combine the statements, you still don't have enough information to definitely answer the question, is A over B less than X over Y? Okay, so that's picking numbers. I am sure there is an algebraic way to solve it, but this is the fastest way for me. So if you have an algebraic way and you want to email it to me, or you want to telepathically send it to me with your brainwaves, that would be great. But make sure you can do it in 2 minutes or less. Okay, so any questions, put those in the chat box. I'm going to erase this, and we're going to move on. Okay, inequalities. Inequalities behave slightly differently than equations when we're trying to isolate a variable with a power. That's like x squared or x cubed or something. So the behavior differs depending on whether this power is even or odd. All right, one thing to note about even or odd powers, when you raise something to an odd power, it's going to have the same sign as the original number. So if you think about -2, so -2 times -2 is +4, but then -2 times -2 times -2 is -8. So if -2 to the 1 or to the 3 or to the 5, you're going to get a negative number. -1, or sorry, -2 squared or to the 4th or to the 8th, you're always going to have a positive number. So anything to an even exponent, you're going to have a positive number. Anything, positive or negative. Anything to an even exponent, you're going to have a positive number. Anything to an odd exponent, well, it could be positive, right? Because like 2 cubed is positive, but -2 cubed, that's negative. So it's going to have the same sign as the original number. Good to know. Okay, let's see what happens in each case for inequalities here. Okay, with an odd power, examples of inequalities with an odd power variable are x cubed is greater than 27, or y to the 5th is less than -32. Great. So for odd powered variables, there's no difference for how you would isolate the variables in an equation. So if you have x cubed is greater than 27, then x has to be greater than 3, right? That seems right. X has to be greater than 3. Or w to the 5th is less than -32. W has to be less than -2. That makes sense. Okay. Okay, we did this. I'm not going to do number 1. Okay, for an even power, examples of inequality with an even power are z squared is greater than 4. Okay, so since even degree equations yield multiple solutions, you're going to have similar behavior, multiple solutions, but with inequalities. So just to sketch this out here, if z squared is greater than 4, right here, then certainly z could be greater than 2, right? Because if it's like 3 squared, that's greater than 4. That works. But -3 squared is also going to work. So basically what you're going to end up with, what I want to end up with, if this is my number line, here's my 2, here's my 2. I'm going to have this into infinity colored in, and I'm going to have this into infinity colored in. All right, so let's go see what the next slide holds. All right, so isolate z and z. We just did this. We did all this. Okay. All right, so um, so just to fill in what Ready4 has prepared for us here, we isolated z squared. We pretended this was an equal sign. Then we got z is equal to plus or minus 2. So z could be positive 2, z could be negative 2. So then you put your roots on the number line. So here are your roots. You have a root at 2 and you have a root at negative 2. And then you try to figure out, using common sense, is z going to be in between these, or is it going to be off to infinity? Remember what I told you last time. If you have a greater than sign, it's going to be off to infinity. Phew, phew, phew. Always with that sound effect. Whenever you're going off to infinity, I expect you to make that sound effect in the testing center. Phew, phew. If you don't, you only get partial credit. That's not true. Please don't do that. And if it's less than sign, it's between the two roots. So if it were z squared is less than 4, it would be in this zone, right? Okay, so that's how you combine math, you combine inequalities with an even root. You transform it to the inequality to an equal sign, and then you use common sense to determine which side of the roots hold the solutions. Okay, I'm going to have you do the next problem right now. Go ahead, I'll give you about a little less than 2 minutes. Go. Yeah, give me another 20 seconds. All right, opening the poll right now. Two more people. Please vote. You gotta vote. One more person. One more person vote. Vote, please. Vote. Okay, good. All right, so here are the results. We had an even split between B and D, with someone choosing A. So very interesting. For those of you who chose B, bravo. For those of you, everyone else, well, let's see what happened. Okay, let's check this out. Okay, if A squared minus 10 is less than 1590, then how many integer values can A have? I don't know. I need to do a little bit of work, first of all. So how many of you did this first and foremost? How many of you brought the negative 10 over to the other side? Raise your hand. I can't see you, but please raise your hand and, like, you know, swear that from now on you will make your lives easier by bringing the 10 over to the other side and making some sense of the equation before you get into the answer choices. So that helps a ton, because if a squared is less than 1600, hopefully this looks like a perfect square to you, also a perfect SAT score, if you know what I mean. But it's also a perfect square. A squared is less than 40. 40 times 40, I think. So, sorry, not a squared. A is less than 40. It's 1:30 in the morning. So if A is less than 40, oh, wait a minute. A is less than plus or minus 40. So here we go, same thing. Here's your 0. Here are your roots. You have 40 and you have negative 40, and it is less than. So is it out to infinity, or you don't have to make that sound effect. The infinity one you have to make, but the in between the roots you don't have to make. It's in between negative 40 and 40. And it says, how many integer values can A have? Here's my question. Let me write this again. A is less than plus or minus 40. Can A be 40? Can A be 40? No, because A has to be less than 40. Can A be negative 40? No, because A has to be between 40 and negative 40. So yeah, it just occurred to me that my notation is not perfect. Technically, what this is A is less than 40 and greater than negative 40. That's the technical math notation, but this kind of gives you the gist of what's happening. The two roots are 40 and negative 40, and it's between the two roots. Like between two ferns, but less hilarious, unless you are on drugs, and then this math problem will be just as hilarious as between two ferns. For those of you who are international and do not know between two ferns, please Google between two ferns Obama. You will enjoy it. So, all right, so it can't be 40, it can't be negative 40, it can be all the integers between 40 and negative 40 plus 0. Plus 0. So for the unfortunate soul who chose A, it's not A, it's 39 negative, 39 positive, and 0. So that's 79. 79 different integers. So well done, everyone who got B. Any questions, put them in the chat box. Okay. Paul has a question of some sort, but it is an indeterminate question. There is you have supplied a sentence fragment of a question to me, so I will wait to see if Paul has any additional comments. Seeing none. All right. None. Great. Okay, absolute values. Examples of inequalities with absolute value are absolute value of x minus 2 is greater than 3, or absolute value of y is less than 4. Super. This is very similar to what we just did, where you have two solutions, and when you have a greater than sign, it's going to go out to infinity, and when you have a less than sign, it's going to be in between the two roots. Okay. So let's look at how to solve these. So if you isolate x in the absolute value of x minus 2 is greater than 3, then you have x minus 2 is greater than 3, and negative x minus 2 is less than 3. So you have x is greater than 5, and negative x plus 2 is less than 3. So now you have negative x is less than 1, and you have x is greater than negative 1. Is that right? Did I do something wrong? Well, let's draw this out and ask if this makes any sense. So look what happens. 5, -1. Okay. It's a greater than problem, which means here are my roots. And I can go one of two ways. I can either go out to infinity, or I can go in between. But I have x is greater than 5. So I'm going out to infinity. That's what's happening here. And then here, I messed up because I switched the sign twice. So it has to go out this way. I'll show you what it looks like. This here, wrong. It should be this. It should be negative x minus 2 is greater than 3. And then do it. So then do negative x plus 2 is greater than 3. Negative x is greater than 1. And then you flip the sign. So x is less than -1. So there you go. X is less than -1 and x is greater than 5. So that's how you do that inequality. Note that, first of all, I said this a couple times ago, but I'll say it again. It's okay to make little mistakes, and you will see me make little mistakes, not just in the middle of the night, but at any time. As long as you catch them, you have to catch them. So when I got x is greater than 5 and x is greater than -1, that makes some sense. It's not something that can happen, certainly not in the GMAT, so they either have to go out to infinity or be between the two roots. So it's as long as you catch it, get the right answer, move along. So let's erase these and move to the next question. So go ahead and try to do example 8. I'll give you about a minute and 10 seconds. Go. Okay, another 30 seconds. Five seconds, and we're going to open the poll now. Okay, very interesting split. Check this out, guys. Wow, that is a tight tug of war. All right, well, let's check this out. We're going to eliminate straight off the bat A, B, and D because none of you chose it. And one group of you, either the C's or the E's, one group of you is correct. Let's see. Okay. Well, which of the following inequalities is the algebraic expression for the shaded part of the number line above? First of all, it should be a greater than or equal to sign. Why is it a greater than or equal to sign? Because this is shaded in. This is colored in. So when you can choose 1 and 5, then you are greater than or equal to, or less than or equal to. When this is an open sign, so if you had, sad number line, if you had like this is 0 and then this is -1, and you can't choose -1, I draw an open circle, just notation. Okay, not A, not B, not D. Well, here's the question. Is this the space between your is this half the space between the roots and this is how much it is shifted? Or is this half the space between the roots and this is how much it is shifted? So basically, what's going on? What exactly does this term do? And what exactly does this term do? And what exactly does this term do? What does this term do? And what does that term do? Well, I'm gonna give you an example. If x, the absolute value of x is greater than or equal to 2, then what do you have? You have your 0, and then you have 2, and then you have -2. And it can go off to infinity, or it can go off to infinity. So here you have half the distance between the roots is 2. And so what does that make this? This is how much it's shifted. So this is shifted. So basically this is what it looks like. You have off to infinity, and 4 between it. But this gets shifted, everything gets shifted 3 over to the right. And that is what this is. Everything just got shifted, so this is your new 0, this is your new +2, this is your new -2. So the answer, my friends, is E. So good job, those of you who chose E. How would you have figured that out? I would have chosen, I mean, you can just know that. You can, you can know that what's inside the absolute value is how much the whole thing gets shifted by, and that this number on the other side of the inequality is half the distance between the roots. But you can also pick numbers if you like. So there are multiple ways to solve this. Any questions, please put in the chat box. Okay, I'm going to keep moving. If I miss your question, I will catch it in the middle of the next question and address it. But let's keep moving on. Okay, review of topics algebra. We're just going to do one more, and then we're going to skip to the next quant lesson here. So this is what we've done in algebra. We've done variables, algebraic expressions, one variable, multiple variables, and a bunch of stuff in inequalities. Awesome. So now we have done one of these before, but I want you to really practice this. This is a 600 level, like hard-ish question maybe. But you really, really, really need to get these right to touch the top level questions. So go ahead and take a minute and 40 seconds with this. I will wait starting now. Go. Okay, another 30 seconds. All right, going to open the poll. Go ahead. Question number 9. . Okay, 2 more people, please vote. Vote, vote, vote. Vote, 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 vote. 1 more. Okay, closing the poll, sharing results. Okay, excellent job. Excellent, excellent job. Everyone who got D, very, very, very good. Okay, I'm going to zoom through this since most of you got it. John is 10 years younger than his cousin Mark. Great. So if, there's Mark. And John is Mark minus 10. Okay, in 20 years, so in J plus 20, how old will John be? Who knows? I need to know how old Mark is now and how old, and that'll do it. Okay. 5 years ago, so the answer to this is who knows. 5 years ago, okay, Mark was twice as old as John. So, so 5 years ago, Mark was twice as old as John. So m minus 5 equals twice j minus 5. Oh, look at this. You have 2 equations and 2 unknowns. You're going to be able to figure it out. And so, so A is sufficient. There goes B, C, and E. And now you test statement 2 alone, so you forget everything, everything you know, and you start over. And you say Mark's age in 5 years, m plus 5, will be twice John's age right now. Look at that. 2 equations, 2 unknowns. So m plus 5 equals 2j, and then you also have m minus 10 equals j. And that should be enough. So each of them on their own sufficient. So the answer is D. Great job for everyone who got D. Any questions, please write them in the chat box. Okay. We're going to skip this question because it is a very long explanation, but I do want you to do it because it is less hard than it looks. There is one thing that you do quickly, and then you can basically isolate X rather quickly, and then it's up to you to use common sense to figure out which of the statements are going to yield something worthwhile. So there's also a fun trick, which is that once you figure out which statement is definitely true, another statement which is very difficult doesn't matter as much. So that's my hint on this one. Okay. So please do that on your own for homework, and I will go over it in email form or at another class. Okay. Algebra takeaways. Know the difference between expressions versus equations. Equations have an equal sign. That's why they're called equations. Use many ways to solve equations. You can use plugging numbers. You can use simultaneous equations. Lots of things you can do. Recognize which strategy is fastest. Remember, this is not a question of whether or not you can get the answer. They know you can get the answer. The question is, can you get the answer in 2 minutes or less? That's not part of the test. That is the test. The test is, can you do it in 2 minutes or less? Sometimes your boss will say, I don't care if you can do this. Eventually, I want it done by the end of the day today. So this is the standardized test version of that. They just want to know, can you do it in this artificially constrained amount of time? Inequalities, just remember everything we worked on. Basically treat the inequality like an equal sign in many cases, but remember when you multiply or divide by a negative, the sign flips. Very, very important. Okay? Ready for homework, please finish the algebra sets that you did not do. Okay? So finish the sets and finish also the problem solving and data sufficiency questions that you have not done. Okay? That's it for lesson 3. let's take a deep breath and dive into lesson number 4. Here we go. Any questions on lesson 3? Please put it in the chat box as I ramp up for lesson number 4. Aha, we have a question. Patrick says, when 5 years ago does not include a right now, you subtract 5 from both sides. When 5 years ago does not include a right now, you subtract 5 from both sides. 5 years ago, Mark was twice as old as John. Yeah, that's right. You do subtract 5 from both sides. If I did not do that, I apologize. But Patrick is correct. You subtract 5 from both sides because it's saying 5 years ago, comma, Mark was twice as old as John was. That would make it more clear. But I agree with Patrick that it was both John and Mark were their 5 years ago age. Okay. All right. Any other questions? Put them in the chat box. Okay. Lesson number 4. All right. Here we go. We're going to do FOIL and factoring, quadratic equations, functions and function symbolism. I just want to say, functions and symbolism is my favorite thing. Not in life. I love my girlfriend and family, but just right under those, functions and symbolism. It's so good. I can't even tell you, it's so good. Sequences and series, that's my third favorite thing. Sequences and series, definitely my third favorite thing. And then consecutive integers and sums, don't care for them, but I have to know them. Okay. Learning objectives. Familiarize yourself with FOIL and study how to do it and break apart quadratic equations, blah, 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 blah. Gain useful strategies to help navigate the test's tricky use of symbols and special functions. Yes. Sequences and series, so good. And define consecutive integers and discover shortcuts to find their sums. Fun fact, you don't need to know the quadratic equation by heart. You don't need to know any of your linear algebra or advanced calculus. This is pretty basic stuff. You have to know it pretty well, and you have to be able to turn it over in your head and come up with some creative ways to solve what are essentially a bunch of simple problems stacked on each other. That's how they make algebra hard on GMAT. Okay. What is FOIL? FOIL is first, outer, inner, last. It is how you multiply binomials that look like A plus B quantity times C plus D quantity. So how do we use it? We do first, I'm going to put out my pen here. You multiply the first numbers in each of the binomials. So you multiply A times C, that's the first. And then outer, that's A times D, right there. And then inner, that's B times C. And then last, the last one is B times D. So, for instance, if you had A plus B times C plus D, you would do the first, which would be AC, plus outer, which is AD, plus inner, which is BC, plus last, which is BD. Okay, so that's what FOIL looks like. Great. Generalizing FOIL. FOIL just applies the distributive rule. Every term in one group has to be multiplied by every other term. There you go. Same applies for trinomials and everything else. Okay. How do we expand x minus 2 times x plus 6? Well, same thing. First, x times x is x squared times outer, which is plus 6x, inner minus 2x, last minus 12. So you get x squared plus 4x minus 12. That's what happens when you combine like terms. So if you saw that, you will be expected to say, huh, well, what two numbers, I'm going to start with x, I'm going to start with x's here. What two numbers will add to positive 4 and multiply to be negative 12? Well, we're going to get 6 and 2. And what's going to add to positive 4? I'm going to need more plus 6 and some x minus 2. x minus 2. Apologies for my serial killer handwriting here, but this is x minus 2 times x plus 6. Great. Okay, factoring. Factoring is the kind of analog to before. It's similar, you know, undoing of the distribution property. So when you distribute, you do 2 has to be multiplied times x and times 3, and factoring is taking something out of 2x plus 6. So think of factoring as like vacuum sealing, where you're kind of condensing a distributed thing into as little space as possible. Okay, factor common terms, factor by grouping, factoring quadratics. We will do all of these through practice. So common terms, let's do this example here. If you factor this, let's see, common terms, well, you got some -5s here, so you factor that out. You got some x's. How many x's? Well, they share 2 x's and they share 1 y. So what's left? Well, we have x and we have, that's it. And a 5, that's it. So -5 times 5 is -25. Yeah, that's it. So, so that's how you factor something gross like this. You take all the common terms, your numbers, your x's, and your y's, out of each term. Each term there. Pluses and minus signs, they're like glass walls. You cannot mix them. Just when you see a plus or a minus sign, that's a different term. It's being separated. Okay, we're gonna. Yeah, we'll skip grouping for now because you're going to have an example with grouping just in a couple minutes. But you can read what it says, group the first several terms together, then the remaining terms, and factor out the common terms. Very good advice. Factoring quadratics when a does not equal 1. So find the factors of. Oh man, this is not something I want to go into right now. So I'll tell you what. I will do this one if it comes up in a practice one, and I will do the quadratic formula if you need to. You know, this is very unlikely to come up on the test where you can't plug in numbers for x. So I will come back to this if we need to. Okay. Yes, use can factor in quadratics when a equals 1. Use the same process, but use. So the quick method is to do exactly what I did before, where you have an x plus or minus something, an x plus or minus something. You're finding something that multiplies together to be C and adds together to be B. That's it. Okay. Common patterns. You got to know difference of squares. So that's really the one thing on this page that you absolutely must memorize. I don't tell you that you absolutely must memorize stuff very often, but this is something you need. A squared minus b squared equals a plus b times a minus b. You got to know it. It's called difference of squares. It shows up all over the place. Got to know. Got. If you can figure out on your own using FOIL, this is a plus b squared and this is a minus b squared. They look like this is a minus b squared and this is a plus b squared. Good to know. Please recognize these patterns on test A, especially difference of squares. You have got to know difference of squares. We're going to skip number 1 because it is incredibly complicated as an explanation, but it is good to do on your own as homework. And we're also going to skip number 2 for the same reason that it is a very long explanation. Okay. Couple things on quadratics. Quadratic equations have this form. They either have one solution or two solutions. Almost all quadratics have two solutions. So most quadratics look like this. You have x squared minus x minus 6. So you have something x, they add together to be -1, they multiply together to be -6, so you're going to have a 3 and a 2 minus plus. So your solutions, or your roots, are 3 and -2. And so that's a quadratic with two solutions. Here is a quadratic with one solution. X plus 4 times x plus 4. So you have x squared plus 8x plus 16. Guess what? Your only solution is x equals -4. That's it. Okay, so when you have a binomial squared, a plus b times a plus b has only one solution. But that's only with the a plus b quantity squared. That's relatively rare, but be on the lookout for it, just in case. Okay, solving equations by factoring. Not going to do this slide, but it is an important lesson, but we are going to learn this lesson through the problems we're about to do. Okay. We will do this inside the problems. Okay, let's do this one. I love this problem. Please do example number 3. I'll give you a minute and 40 seconds. Go. Another 1 minute. Okay, another 5 seconds. And I'm going to open the poll right now. Wow, this is very interesting. Huh. 2 more people. Please answer 1 more person. And good. Okay. All right. Well, good for almost all of you. Very, very, very good. Answer choice C, it is. It is answer choice C. So I'm going to go through this very quickly because most of you are brilliant and got this one correct. But let's check this out. For how many unique values of x does that messy thing exist? Well, I hope most of you saw that it would be really nice to factor out x squared. And once you factor out x squared, you get x squared minus 4x plus 4 equals 0. So now you have x squared equals 0. So 0 is one of your roots. And then you have x squared minus 4x plus 4. Yikes. So that means they have to multiply together to be +4 and add together to be -4. Well, that's x minus 2 times x minus 2. So you can either have 0 or you can have 2, and that's it. Those are the only possible values of x. So those of you who got C, excellent job. Everyone else, more factoring practice. Speaking of factoring practice, I do want you, especially in lessons like this one where we are hauling through the slides, I want you to review the slides, and I want you to redo the questions that you solved, especially if you missed it. And I want you to redo the questions if you think you can go faster. I want you to try different approaches to the problems, and I expect you to do all the problems we skip, because these problems were written for a reason, they're in the lesson for a reason, and if you can do the hard ones with the long explanations, you'll be in great shape. Remember, you not only have the slides without the explanations, the ones that we're going through, well, you also have the slides with the explanations, so you can go over those at your leisure. And if you still need more explanation or want a faster way to do it, you can always email me. Okay, so let's move on to the next one. Here we go. All right, go ahead and do this one on your own or right now. Go. All right, another 40 seconds. Okay, I'm gonna open up the poll and see how you guys did. Oops, open up a new poll. Here we go, go. Oof, yeah, pretty big distribution here. All right, 2 more people. There you go. All right, check this out. Half of you, very, very, very good job. It is E. The other half of you, it's tough. So we'll hide that and go through it. Okay, let's check this out. What is the value of A cubed? I don't know. Who knows? But what I do know is to find the value of A cubed, I gotta know A. I really have to know A. That's what I have to know. Because what if I knew A squared? Would that be enough? No, not enough. Because if you know A squared, it could be the root, it could be the positive root, or it could be the negative root. So you don't know. So you gotta know A. All right, so statement number 1, you have A squared minus 3A minus 4 equals 0. So I have to multiply -4 and add to -3. So I got A, multiply -4, so I got 4 and 1, and I got +1 and -4. So I could have -1, I could have 4. So that's not enough. All right, so now statement number 2. Statement number 2 alone says A cubed minus 4A squared minus A plus 4 equals 0. Yikes. Yikes. Is there any way to solve that? Oh, well, you could pull everything else to the other side and say that a cubed equals 4a squared plus a minus 4. And then you can solve this, but this is a mess. What if it said a cubed equals a minus 2 squared? Is that enough? Yeah, that would have been enough. But that's not what it says. It says this mess here. And I actually don't know the answer to this. I know you can have 4a and a, or you can have 2a and 2a, and then try to figure out that mess. I could use the quadratic formula, but I'm not going to do that. Basically, I don't think that statement 2 alone is enough. It's too messy, and I only have 2 minutes. So I combine them, and basically, I'm going to want to know, can you have, I'm going to try to plug in 1 and see if that works. 1 equals 4 plus 1 minus 4. Yep, that works. And then I'm going to try to plug in, I'm going to try to plug in -1, and I'm going to try to plug in 4. And if they both work, then I don't know the exact value of a, which means I don't know the exact value of a cubed. So I'm going to pretend I did that, and the answer is E. E is the answer. So for a more fulsome explanation, please check your explanation on your PDF for lesson 4. If you need any other, if you have any other questions on this right now, go ahead and ask that in the chat box. Okay. Seeing none, I'm going to keep moving. Functions and symbolism. Functions are my favorite thing. Here's the thing about functions. Functions are designed to make you go cross-eyed. They are designed to make you think, what? I've never seen such a symbol before. I don't know what f of x is. I'm going to give you a very, very, very quick tutorial on functions. Here's how a function works. If I say that f of x equals x squared, whatever is in these parentheses, you square it. So basically, I just gave you a little dance, a little two-step, a little tutorial. Pretend that I am like your GMAT International Man of Mystery, and I said, listen, student, I'm in an undisclosed country, but I have a secret for you. Whenever you have an x, maybe even an x plus 3, there is a way that you can manipulate it, a way that you can f it, if you will. To f this innocent x plus 3, all you do is square it. That's it. Just square it. That's it. So whatever is in the parentheses here, you square it. So what if I told you f of x, International Man of Mystery here, is x plus 3? Well, that's a different way to f. Maybe that's how they f in, in like Fiji or something. They just add 3 to it. So if I told you f of x is x plus 3, what's f of x squared? Well, just add 3 to x squared. So that's it. And that's all a function is. That's it. That's it, whatever they tell you to do. Fing is whatever's, whatever's in the parentheses, they tell you how to f. And then you do that to something else. They tell you how to f x, so you f x squared, or f x plus 2. Just don't f out in public, just on the test, please. This is only word, anyway, I'm going to move on. The other thing that they might do is they might have strange symbols like brackets A. So bracket A is 1 over A minus 3A. It's the same thing. It's the same thing as the functions. So bracket A just means you 1 over it minus 3 times it. So what the heck is, for instance, bracket A squared? Well, you 1 over it, and then you subtract 3 times it. That's it. That's bracket A squared. That's all you do. They're trying to confuse you, but it is very, very simple. Okay? That's it. When functions or symbols are nested within one another, solve from the inside out. So we'll do that in a minute. Okay. How to use special functions, given that a blarg, I use blarg all the time because these symbols are nuts. So give it some goofy word like a covfefe b or something. So if a covfefe is b, that just means that a times b. That's it. So what's the value of 2 covfefe 3? It's just 2 times 3. That's it. It's 6. So given that x covfefe y covfefe z is that mess, if n covfefe 6 covfefe 9 is 0, what's the value of n? Well, they just told you that this whole mess is that whole mess. So this is n squared plus 6 times 9 plus 9. And they tell you that that equals 0. So what's n? Well, this, I believe, is 54, and this is 9. So, so 54 plus 9 is 63. So n squared is, x squared equals negative 63? Well, if that's right, then n cannot exist. So this must be a typo because you can't. This is the imaginary square root of almost. It's almost imagine. It's almost 8i, and that is not a thing on the GMAT. So we'll fix that. But that's generally how the special function symbolism works. Okay, let's move on. Go ahead. Nope. We're gonna skip. We're gonna skip this because this is the explanation is a little too tough. But really, really, really want you to do this in practice because this is another one that's not as hard as it looks. It's just going to take about 6 minutes to finish. So let's do one that takes a little bit less time. Like this one. So go ahead and do example 6. I'll give you 2 minutes. Go. Okay, we're going to give you another 30 seconds. All right. Okay, launching the poll. Well done. Okay, we have a pretty solid split here. Most of you, about 2/3 of you, think it is D, and the rest of you think it is B. All right, we can agree that A alone is not enough. Well, actually, the D folks think that A alone, or statement 1 alone, is enough. We both agree that statement 2 alone is enough. So let's just deal with this statement 1. Okay, statement 1 says that K is M minus this greatest integer less than or equal to M. So here's my question. What if M, what's the M of 36? Is 36. That's it. What's the M of 36.9? So what is the M of 36.9? The greatest integer less than or equal to M is 36. So K is M minus the little funky thing of M. So statement number 1 says that K might be 0, or it might be up to 0.9, or up to 0.9999999. So, sorry, I miswrote this. The blank of 36 is 36. The bracket of 36.9 is also 36. So if M minus the bracket of M could be 36.9 minus this bracket of 36.9. So it could be 36.9 minus 36. Could be up to 0.9, but it cannot be 1. And it cannot be greater than 1. So guess what? Statement 1 is enough. Statement 2, definitely enough. And the answer is D. So great job, everyone who got D. Any questions? Please put that in the box, chat box. Okay, sequences and series. Here's the thing about sequences and series. You have a bunch of numbers. They go, it's like term 1, S1, S2, S3. That's just it's like things in a row. So if the first term is 1, the second term is 1, the third term is 2, the fourth term is 3, the fifth term is 5. That's your Fibonacci sequence. And all equals S to the n minus 1 plus S to the sub n minus 2. What the heck does this mean? What in the world does that mean? That means the nth term, let's say it's the third term, is the term before it. This is the term before S to the n, or S sub n, plus the term before that. So guess what? The third term is the sum of the second term plus the sum plus the first term. That's what this is saying. S sub n equals the term before it plus the term before that. So S sub 4 is S sub 3 plus S sub 2. That's it. That's all it says. It's not a big deal. Don't freak out. So, so there you go. If S sub n is the term before it plus the term before that minus 3, then you can figure out what's going on from that. Okay? That's all it means. S sub n minus 1 just means don't freak out. It just means the term before the term you're looking for. That's it. That's all it means. Okay? S sub n minus 2 just the term before that. That's it. It's not going to be more complicated than that. They're trying to bamboozle you with lots of letters. Don't be bamboozled. Okay. Go ahead and do example number 7 right now. Okay, I'm going to open the poll right now. Okay. Good stuff. Very interesting. All right, one more person. Please vote. Please vote. Vote, 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 vote. Great. Okay. Plurality, 38% of you got the correct answer. Good job for those of you who picked A. The rest of you, let's figure this out. This was not easy. Okay. So I take that back. This is easy. This is a sequence and series problem. Okay, the sequence of n numbers, each term after the first two terms, so starting with s sub 3, and then s sub 4, and then s sub 5. So the s sub n equals the product of the two ones right before it. Got it. S sub n minus 1 times s sub n minus 2. Super, great. So s sub 3 is s sub 2 times s sub 1. And s sub 4 is s sub 3 times s sub 2. And s sub 5 is s sub 4 times s sub 3. Great, got it. What's the fourth term of n? Oh, it says none is equal to 0. That's just so, like, none of this is 0. Good, thanks a lot. Okay, what's the fourth term of n? I don't know, could be anything. All right, the fifth term of n divided by the third term equals 18. Check this out. Check this out. S sub 5 is S sub 4 times S sub 3. Let me write this again. Up here, S sub 5 equals S sub 4 times S sub 3. Well, divide both sides by S sub 3. And you get down here S sub 5 over S sub 3 equals S sub 4. S sub 5 over S sub 3 is 18, and that is enough. So you're down to A and D. And so you test statement 2 in isolation. The third term of n times the fifth term equals 648. The third term times the fifth term, does that happen anywhere? So S sub 4 is equal to S sub 3 times S sub 2. And so really, so that's not going to work. That's not going to give me S sub 4 alone. S sub 4 alone is S sub 5 over S sub 3. So statement number 2 is not enough. There goes D, and the answer is A. So how did I know that? It's just, I mean, I'm looking at that and I'm thinking, gosh, if I have an S sub 5 times S sub 3, is that useful information? Does that come up anywhere? No. What I want is S sub 5 divided by S sub 3. Right? And those are different things. If you have any questions on that, write it in the chat box or send me an email anytime. I love sequences. Love them. Okay. We're going to skip example 8, but I want you to do it on your own at home. Please, please, please. I love sequences. Consecutive integers and sums. Consecutive integers are integers that follow each other in immediate sequence, like 1, 2, 3, or n plus 1, n plus 2. Consecutive odd or even integers can be generalized by n plus 2, and then n plus 4, and then n plus 6, where n is either odd or even. Good to know. Sums of consecutive integers. Here's the thing. Sums of consecutive integers are asked in very similar ways, and the formula is the same thing on every kind of consecutive integer problem. You should know this formula. The sum equals the average times the number of terms. Please read slides 26, 27, and do these problems on your own, 26 and 27. I'm going to show you right now how to do example number 9 in 2 different ways, both of which will take 30 seconds. Here's the first one. 1 plus 2 plus 3 plus blah, 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 blah. Do not start adding. Don't add 1 plus 2 is 3 plus 3 is 6. You'll never finish. That's not right. Here's one way. I call it the rainbow sum method. 1, 199. 2, 198. Okay, well, each of these sums is summing to 200, right? And how many pairs do I have? Well, this is going to go all the way up to 99, so 99 pairs plus 100. So 99 times 200 plus 100. Okay, that's one way to do it. Another way to do it is what's the average here? The average is 100, and 100 times how many terms? Well, it looks like we got 199 here, and I think that is also the answer. But let's see, 99 times 200 is like 99 times 2 times 100. So you get 198 times 100 plus 100. So you get 199 times 100. Yay, same thing. Thank goodness. Okay. By the way, 199 times 100 should be and is that one. Excellent. Okay. Those are the two different ways you can do it. You can either do your rainbow sum, or you can do average times number of terms. Okay, please read slides 26 and 27 on your own. Boop, 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 boop. Okay. All right, and you know, this is kind of interesting. I want you to do number 10 on your own. I want you to do number 10 with me right now. I want you to take a minute and 20 seconds, do as best as you can right now. Go. Give you another 20 seconds. Five, four, three, two, one, and here we go. All right, tell me what you got. Very good. 3 of you still need to vote. Please vote. 3 people. 1 more person. Great. Okay. So 75% of you, that is correct. It is C. And the 25% of you, this is pattern recognition 101. So let's go to how many different numbers between 12 and 12,000 have both the digit 3 in the unit place? Remember what the unit place is. It's the thing right next to the decimal, 3, and the digit 1 in the tens place. Oh my god! Oh my god! This is only asking how many numbers end in 13. Well, 13 ends in 13, 1 13 ends in 13, 2 13, 3 13, etc. all the way down to 9 13, and then you're going to start over. So how many of those you got? 1 2 3 4 5 6 7 8. Sorry, 1 2 3 4 5 6 7 8 9 10. This is the 10th 10th one digit, that the 10th number that ends in 13. You have regular 13, and then 1, 13, 2, 13, 3, 13, etc. And then you start over, and you get 10 more, and then you get 10 more, and then you get 10 more. So you get, so how many times do you get sets of 10? Well, you get 10 up to 1,000, 10 from 1,000 to 2,000, 10 from 2,000 to 3,000, etc., all the way up to 12,000. So you're going to get an even 120. And that's it. Okay, so count how many are in a set, and then figure out how many sets you got. That's all there is. So any questions on that, please put it in the chat box. You guys are killing it right now. It's almost like you are watching this, not at 2:30 in the morning. It's very impressive. You guys are very impressive. Okay. We are going to review FOIL and reverse FOIL, quadratic equations, functions, symbolism, super easy, sequences and series. You've got it down, consecutive integers and sums. There are many ways to solve it, and you are very good at consecutive integers and sums, both of you. Please do this last one on your own in practice. Example 11, same thing with example 12. I love example 12, but you got to do it on your own. Same thing with example 13. Here are the takeaways. Please use and recognize when and how to factor certain types of expressions and equations. Be able to recognize differences of squares, recognize special functions, and sequences and series are not as complicated as they are trying to make you believe. That is the #1 thing with functions and series and sequences. It is not that tough. Just figure out how to say it in plain English and realize that once you understand how to F, your whole life is set. Your life is easy. Easy once you know how to F. Okay, know how to work with consecutive integers. That is that on the algebra lesson for the 4th session. So do the algebra 2 sets 1 to 3 and do problem solving pages 150 to 267, numbers 43, 61, 149, all of that. Everything listed on slide 35, please do that for homework for next time. Before we launch into the very last part of today's lesson, there will not be office hours tomorrow. I am very sorry, but I will be on a plane. I would do them on a plane. I would do it. Definitely would do it. But unreliable Wi-Fi on the plane. So please email me. We will have class Thursday night, and we will find a time to make up the office hour. I promise you. So no office hour tomorrow morning, but so don't log on. In 10 hours or so, I will be on a plane. Don't do it. But we will make up the office hour, and we'll have class on Thursday. Okay. So please do your homework before Thursday. That's it for the math for lesson number 4. I'm sorry for skipping over those last few. Please do them on your own. Please look at the explanation and ask me any questions at any time. Those questions are just more advanced samples of the stuff that I taught you in the last hour or so. Okay? Any other questions, please put it in the chat box. Miss you in the chat box. Miss you, everybody. Say hi. All right. This is it. We got a half hour. We're going to run through verbal as much as we can. If we don't finish, we will pick it up on Thursday. So here comes verbal. Still nothing in the chat box. Okay. Here we go. Reading comprehension and critical reasoning. We're going to do detailed questions and provide example questions. In critical reasoning, we're going to do completing an argument, filling in the gap, choosing the missing information, and ruling out alternatives. All right. This is what we're going to do today. This is how it goes. You will see exactly what we're doing as we move along. So first things first, detailed questions and providing sample questions in reading comp. Okay, detailed questions ask you to identify minor ideas that are being explicitly stated in the passage as opposed to being inferable from the passage. So these are stuff that's in there. You don't have to make any inference or any sort of logical connection. It's just like asking you, did you read it? Did you really read it? Like for real? Did you understand what was going on? That's what a detailed question is. It's asking you about the passage. Did you comprehend the reading that we just asked you to? Function question asking how a particular idea relates to the main point of the passage. And providing sample question makes you choose which scenario best illustrates an idea. Using the GMAT would teach you. When you are doing reading comprehension, you are going to be tempted to skim the passage, I don't do that. I read it and try to comprehend it. That's what happens. Explain what's happening. Oh, I just heard, just as I was about to impart some very, very valuable wisdom, that my connection was spotty because the GMAT overlords do not want me to tell you. So I'm going to ask my assistant, am I clear? My back. Now, good. Okay. All right. So hopefully we will continue for the next 25 minutes. Clear. All right. Here's the thing with reading comprehension. You got to understand what is happening in the passage. I know it's boring. I know it is scientific. I know it is very, very technical. It's designed to be that way. The whole point of the reading comp passage is to put you to sleep. It's to make you feel like it's 2 in the morning during your test. But it's not 2 in the morning. It's always GMAT time. It's always go time. So you have to make the reading passage be exciting in whatever way you can. But mostly putting whatever passage in place. That way you're going to understand the details, you're going to get the functions, you're going to be able to provide an example quickly, and you're going to understand the vocab in context even if you don't know the vocab word. So underlying all of the Ready4 lessons is reading slowly in a way that puts it in plain language so that you can fully understand what is happening. If you don't understand what's happening, the rest of this stuff is going to be super hard. So let's see how that works in practice. Okay. Also, before we do that, detailed questions are just more about detailed questions. Detailed questions are asking for something to extract specifically from the passage. Accept questions, just a particular kind of detailed question. And here's our passage. I'm going to read this in the exact way that I would read it on the GMAT. So you don't have to read this right now. So just sit back and watch as I read this. And most importantly, listen to the words that I use that are not in the passage. Because when I use words that are not in the passage, that's the most important part of this. Because that's me sorting through, sifting through this thicket, this dense bolus of information and digesting it and comprehending it and getting it to a point where I can absorb it into my intestine and then excrete the right answer. That was gross. I'm sorry, that is a super gross metaphor, but completely accurate. I maintain that that was a good metaphor, just a little more digestible than I thought it was going to be. here we go. Okay. As understandings of the solar life cycle develop. Well, first, here we go. Let's, I'm going to use my pen here. Okay. As understandings of the solar life cycle develop. Okay, so they're people, and there's like a solar, so it's the sun, and it's like being born, and then it's like getting a little teenagery, and then it's going to die. So people are understanding how the sun was born. How the sun was born. How sun born. Not Jason Bourne, how the sun was born. Scientists were confronted by a nagging question. If, early in the history of the Earth's planetary formation, early in the history of Earth, the sun was dimmer than it is now, okay, so not shining quite as bright, much like GMAT students who have not taken Ready4, if you know what I mean. So not shining quite as bright. How do we explain evidence for the presence of liquid water on the planet's surface during that period? All right, here's what it's saying. Okay, there's like scientists are trying to decide how the sun was born. And scientists are asking, early in the history of Earth, if the sun was dim, why was there water? Why wasn't it like all ice or something, right? Huh? Let's figure it out. Okay, it is understood that during the early Earth period, our sun would have shown at about 70% of its current luminosity. That means shininess, significantly below the level necessary to sustain the presence of liquid ocean on the planet's surface. Everything would have been frickin' ice. That would have sucked, except it would have been good for slushies, but not for life. Okay, but paleontological and geological records indicate with substantial certainty that liquid water was present on the Earth's surface during this time. So it wasn't all ice. We had enough heat to make water during early Earth. That is pretty cool. All right, if scientific models of solar development and the early geological history of Earth are to be reconciled, all right, we got solar development, sun history, and Earth history. There must have been some other intervening factor, like a hot Earth core or something, affecting surface temperatures during the early period of geologic history. Okay, we got water early, and there's something going on besides the sun. Cool. The method of reconciling these two apparently contradictory bodies of evidence has been to analyze the characteristics and chemical composition of Earth's atmosphere. Okay, so they're looking for it in the air. They're looking for it in the chemical composition of the Earth's atmosphere. So maybe Earth is surrounded by a fuzzy-wuzzy blanket, and that's what's keeping it so warm. That would have been great. So there's like some sort of Earth Snuggie. I'm going to write Earth Snuggie. Maybe there's an Earth Snuggie. Maybe that's what's keeping Earth so warm. We have known for decades that the presence of certain vapors in the air, commonly known as greenhouse gases, interesting, increases the amount of heat retained by an atmosphere to a degree proportional to the concentration of greenhouse gases within it. Okay, Earth Snuggie might be made of GHGs, greenhouse gases. Just FYI, maybe there's an Earth Snuggie going on and it's made out of greenhouse gases. That would, by the way, do not get your girlfriend an Earth Snuggie made of greenhouse gases. She will not appreciate it. Okay, so that's what's going on. So there's a hypothesis. If the Earth was warmer in the past, then solar luminosity would suggest, really strong evidence that it was, then we can expect additional greenhouse gases. The atmosphere would be paramount value in the squaring of the discrepancy. Listen, that is one giant word vomit saying that, you know what, if the sun wasn't shining so bright, maybe GHGs might have been warming your Earth. Maybe GHGs might have been warming your Earth. That's all it's saying in the most complicated language possible. Heightened greenhouse gas levels would trap and magnify the sun's heat. Okay, bit more greenhouse gas levels, more bigger, thicker Snuggie would trap and magnify the sun's heat as it struck the atmosphere, enabling liquid water to exist on the surface of the earth. They're still talking about the exact same thing. I don't even know why. They just get, it's like they have like a diarrhea of the mouth. They just more words saying the same thing. However, as we have discovered little evidence that greenhouse gases during the early Earth period were present in larger quantities. However, we have discovered little evidence that greenhouse gases during the early Earth period were present in larger quantities than previously assumed. Oh, what? Well, you got this word here, however. That means something is happening that is a little different. So these scientists, they're assuming the Snuggie theory is going strong, Snuggie theory is awesome, but there's not so much evidence that there are that many greenhouse gases going on in the early Earth period. These surprising findings indicate the discrepancy between solar astronomical and geological evidence related to the development of the Earth's ocean cannot be explained by the presence of GHGs alone. So they just spent all that time, and my precious, delicious, softest Snuggie theory cannot explain the presence of water. Okay. One likely alternative is that another non-solar source of the atmospheric heat, like the Earth's core, that was like my whole thing, like volcanoes or something, was heating the Earth during the Earth period. Earth and its moon were much closer together in the early history of the planet, and tidal heating caused by the moon's rotation around the Earth, oh my God, the Earth is like a giant whirlpool. It's like swishing and sloshing, and like the movement of the tides are like they're going up and down so fast that that's creating friction. That's it's like a heated washing machine for the Earth. It's amazing. Seems crazy, but that's what it's saying. Okay. While it's unclear how much influence this phenomenon might have exerted over atmospheric temperatures, seriously, scientists are increasingly convinced that it could play a part in explaining the unlikely presence of liquid water on our infant planet. I'm going to call this the jacuzzi theory, that our Earth is a giant jacuzzi, just like the Earth, the waters, things are sloshing around, and, you know, things are just, you know, gravity is pulling the water this way and that, or the ice this way and that, and the motion is creating the ocean. The motion is creating, I just made that up, but I like it a lot. Perhaps in combination with indeterminate geological activity, that's my volcanoes, solar flares, or irregularities in the Earth's magnetic field. That's the passage. That took a while, but the questions are going to be super easy and super clear when we start the questions. I totally understand this passage. It is a science passage. It is technical. There were lots of sentences that were redundant, that used very technical language. But, oh, sneezy time. You know what? I think it's because the Earth jacuzzi is like getting it. No. Listen. If you make it clear, if you put the words on the page into your own words and give yourself a chance to understand the passage on your own terms, understand it on your own terms, you're going to give yourself your best shot of getting the questions correct. So now let's go see these questions. First of all, any questions on the way that I rephrased the passage? Go ahead and put those in the chat box. Okay, here we go. Okay, the authors propose all of the following is possibly explaining the presence of water on the surface of the early Earth, except, all right, well, I'll give you 30 seconds. Go. Okay. Now it's tricky because I said I mentioned this word that is in that, but this was not. It's not in the passage. So hopefully you guys can get this. I'm going to open the poll, and then I'm going to answer all the questions that you just had. So go for it right now. Oh man, you guys are killing it. Great job. Great job. It is D. You can see it in the last little part there. Greenhouse gases is what they're talking about most of the passage. And then in the very last part where it says perhaps in combination with geological activity, solar flares, irregularities in the Earth's magnetic field. And of course you remember tidal heating from the jacuzzi theory. So it does not say anything about the volcanic eruptions. I put that in there, but I went back to the part of the passage where it's mentioning all the other stuff, and I didn't see volcanoes. So I also would have chosen D. So excellent job for those of you who chose D. Let me find results. So the questions were, do I make notes? Absolutely. Absolutely I make notes. It is very important to take enough notes so you can remember what each paragraph was about, what's going on. I don't make extensive notes. And one thing I really want to caution you against, do not write notes that are transcriptions of what is already on the screen, because you're not understanding anything, you're just transcribing. Don't transcribe. You can interpret or reinterpret or rephrase, but do not transcribe. That's not helping you. But if you make notes that are sort of like, oh, they're talking about the jacuzzi theory or this other kind of theory, that's helpful. Suhas, how to make sense of them inferring that greenhouse gases is carbon in the atmosphere. That's a scientific fact. So that's something that you should know, but if you don't know, you can infer it. You can infer it from the passage. Okay. Ooh. Man, it's the greenhouse gases coming up here. Okay, Patrick, how much time do I take to read the passage during the test? For an average passage, there are going to be 3 to 6 questions. So if, let's say there are 5 questions, I will take about 6 to 7 minutes to read the passage. So if you think about it, let's say 7 minutes for the passage, and then 45 seconds times 5. That is, so minute and a half, 3 minutes, about 4 minutes. So I end up doing that's about what I do, and then I generally do the sentence correction questions a little faster, and the critical reasoning questions in about a little under 2 minutes as well. I always finish the section, and I almost never miss a reading comp question. So that's my method. You can, if this takes you too long, please use the Ready4 methods primarily. But I'm showing you my method because this has really made reading comp a ton of fun, and it's really improved my scores on the reading comp section as well. Okay, so that number 1 was indeed answer choice D. Okay, detail questions. Right answers to detail questions are similar but not the same in wording to the passage itself. They don't mention anything not explicitly stated in the passage. They're easily recognized if you have read the passage carefully. Wrong answers are inaccurate. That's good. They address things not in the passage. They misrepresent or misunderstand or use details from part of the passage, but not the relevant part. Okay. So detail question strategies. Remember where the detail is in the passage. Go to that part of the passage, find the detail, and match it. If you don't remember where the detail is, consult your notes or find a common keyword, you will not be able to search the passage using any sort of help or search method. So you really need to remember what's going on inside the text of the reading comp passage. You can also skim the passage if you really don't remember. Okay. Same passage, different question. So go ahead and do this question. I will give you 40 seconds. Go. Okay, opening up the poll and go. All right, this is amazing. You guys are geniuses. Yes, number 2, the answer is C. Great, amazing. According to the passage, which of the following is true of the sun's luminosity, shininess during the early Earth period, it would have been insufficient to maintain liquid without some other intervening factor. We found that out super early in the passage. And every single one of you got it right. Very, very impressed. Okay, provide example questions. They ask us to demonstrate our knowledge of the passage's argument in a different way than other questions. So, which of the following best exemplifies a case most suitable for expert intuition as it is described in the passage? What? Which of the following is the best example of a case where you need expert intuition? So there's somewhere in the passage that's going to say something about expert intuition. So figure out how that fits into the passage's main idea. So anyway, that was a hypothetical. Let's see if we can find a real one here. Question number 3, go. Oh, wait a minute. This is a completely different passage. Oh, no. Okay, guys. Here's what we're going to do. I thought we had the same passage. We have 4 minutes left, so we're obviously not going to do an entirely new passage. We're going to start with slide 15 next time. Do me a favor and read slide 15 on your own so that we can start actually on slide 16, which is starts the examples. So please read slide 15 on your own. We're going to answer the couple questions that just came in over the transom. Suhas, isn't that an inference? My work focuses on capturing the moment in time, whether it's portraiture. I am not sure what Suhas is talking about exactly. So here's what I will say about reading comp, inference, method of reasoning, all the other jargon. If I or Ready4 or anyone is introducing a technique to you that requires an increased amount of jargon and confuses you, do not use that method, because your job on the test is to quiet your lizard brain, quiet your amygdala, and put the question in plain English and get to the correct answer as quickly as possible. I don't label questions, okay, this is an inference question, or okay, I have to go through exactly this mousetrap, this exact sequence of events in exactly this order to get this question correct. I have a model of what each provide an example, or each detailed question will look for certain kinds of things. but I don't hit, each question is designed to be just slightly different. So if you have an exact roadmap where you have to turn left and then turn left and then turn right, the GMAT is going to do something to you to mess that up. So you have to be as flexible about how you're thinking about the question as possible. Don't label it an inference and then start down your inference path without understanding what exactly it is. What is the content of this question? That's the first thing. That's why I read the reading comp passage the way I read it. That's why I teach this the way I teach it. It's because if you understand the underlying, then the kind of question is ancillary. That's where I want to drive home. For Suhas and anyone else, if you have questions on this, please email me. I'm happy to respond over email. Suhas, I think I did that last week, but if you have anything, please email me. For the rest of you, it is now 10 p.m. on the East Coast, 7 p.m. on the West Coast, 3 p.m. 3 a.m. GMT. I'm sure it is 3 p.m. somewhere. But that is the end of tonight's lesson, lesson 4. We will pick up on slide 15/16 in verbal 4 next time. Please do the math homework only. We will do verbal homework next time. Please focus on the math between now and Thursday. And I will see you all Thursday at 8 p.m. East Coast.